Hello! In this video I'm going to show you how to create a multi-channel visualizer using both MC as well as jitter objects. I'm going to do this by starting from a patch I created in the previous video, a multi-channel panning algorithm / soundscape generator. I'm going to get both the panning and amplitude data from the incoming multi-channel signal. I'm going to convert those into Jitter Matrices and I'm going to feed that information into a jit.gl.multiple, maybe one of the most useful objects in the jit.gl library. So let's start. Okay, first of all, I'm going to make some room in this patch. We don't really need these visual indicators or some of these comments anymore, since we're going to be creating something new. Though the functionality of this patch stays, right? This is still the same panning algorithm patch that creates these soundscapes using the vibes A1 AIF file. Now, what I want to do is two things, right? First, I want to create some kind of visuals where I can take one object and I can create multiple copies of it on the screen. We are going to be using jit.gl.multiple for that. And then I want to take these MC cables, some information coming out of these MC objects, and feed them into that visual system to visualize what is going on here. So let's think, what can we get out of these MC objects? What can we get out of this sound installation? So first of all, we can get the panning state, right? That is going to be left to right, and it is going to have a range of 0 to 1. And we can also get the volume, right? Or the, well, more appropriately, amplitude. We can get amplitude of each channel, which should also be somewhere between 0 and 1, I believe. We can also use, let's say, the playback position. I don't think I will implement the playback position, though that is still each channel, 0 to 1, but it's, in fact, in case you wanted to do something else after this video, you can also see if you can get the information out of the playback position. But right now I want to get the panning state, I want to get the amplitude, and I want to visualize this in some way. So let's start by creating our jitter world context. So jit.world, and then as an argument I should give a name to this context, which is again going to be space, and then I'm going to give it a bunch of attributes such as size, which can be 320 to 240. We can change this later. Full scene anti-aliasing 1, so it looks a bit crisper on our screens, and then floating 1 to enable floating window style, so that this window always stays on top of the world, on top of the patch. And then I'm going to create a toggle just like in the previous video, and if I toggle this on, voila, our jit world context is running. Okay, now I can create an object simply by using jit.gl grid shape, right? It's very simple, very basic stuff. I can give it the attribute of, let's say, lighting enable 1, smooth shading 1 to make it look a bit more visually pleasing. I can even use jit.gl camera and give it a position of 0, 0, let's say 3, so that it leans maybe a bit higher, 0, 0, 5. How about that? There we go, so that it kind of leans away from the camera. Very basic stuff. Now, just like with MC and audio processing in Macs, we can use some tricks to take this single guy and create multiple copies of it. The alternative would be to copy this, give the second instance a different position, right? So we would have one up here, and I could copy this again, and I would put it to the left. And just like how it would be with audio, it would be a nightmare to regulate all these objects and their positions and their colors and their scale and so on. I don't want to do that. So I'm going to use jit.gl.multiple. Maybe one of the most useful objects in the world of jitter, in the world of 3D jitter at least. Okay, so jit.gl.multiple works in a way that's very similar to MC objects. It's going to create an output of multiple something, in this case multiples of a single 3D object. Right, and all we need to do to start this process is to take the first outlet of jit.gl.multiple and connect it to the first inlet of our 3D shape object that we are using, in this case jit.gl grid shape. And as soon as I do that, this object is going to disappear because jit.gl.multiple is smart. It knows to tell jit.gl grid shape that you are not needed anymore. I will take care of things. But we don't have anything here yet, so let's check out the help file of jit.gl.multiple to see what's really happening, how this exactly works. So in this example of the help file of jit.gl.multiple, there is a single jit.gl grid shape object. This is all generated from a single object by using jit.gl.multiple. Right, and we can see that there are some arguments that are given, the name of the Jitter world context, as well as this number 4. Now, this is very important. This 4 doesn't mean 4 instances of the object. The 4 means I'm going to be using 4 parameters. I'm going to be commanding and connecting and playing with 4 parameters of this OpenGL object. And these are later denoted by the attribute GL params, which are position and rotate XYZ and scale and color. So let's think, well, what are we going to use? So ideally, I want to control the position by, using the information from the panning, right? If the sound is going from left to right, I want the shape to go from left to right. And I also want to control the scale so that if that instance of the MC signal is loud enough, it grows bigger, and if it's a quiet sound, it is smaller. And I can also use the color parameter to give each object, each sphere in this instance, a random color, so it looks a bit more pleasing to the eye. Okay, well, so let's see if we can implement this. So I take jit.gl.multiple, I give it the argument space, and then I'm going to be controlling 3 parameters. And so I can type in the attribute GL params, and let's see, so it was position, right, and the scale, and then color. And doing this gives jit.gl.multiple 3 inlets, right? Each one is for a different parameter. The first one is the position array, the second one is the scale array, and the third one is the color array. All of these inlets expect jitter matrices. And I know that jitter matrices and the jitter matrix in general is a complicated topic. It's, you can go very in depth in that topic. You can do a lot of crazy things using jitter matrices. So I'll try to make this as simple as possible. So let's start by just generating random values. I'm going to use jit.noise, which is going to generate a jitter matrix containing random values that go from 0 to 1. If I use float32 data type. So I'm going to give it 3 planes. I'm going to make the data type float32. Always works best with jit.gl objects. And then I need to give the length. Now this 10, right? The fact that this jitter matrix is going to be 10 cells long or 10 cells big or whatever is the deciding factor for how many instances of my object jit.gl.multiple is going to make. If this sends out 10 values, if all these inlets receive 10 values, then there are going to be 10 objects on the screen according to those parameters. Right, if we want to see what exactly comes out of jit noise, I can use jit cell block to visualize the information coming out of jit noise. And as you can see, it's multiple values, multiple random values going from 0 to 1. And since the plane number is 3, if I send a message to this jit cell block, right, planes mining 1 as in show all the planes, and then call with 120, so make the columns a bit larger. Interesting, it should be showing 3 values here. Maybe it should be plane -1. Yes, there we go. Okay, problem solved. So each cell contains 3 values, and we can use this for, X, Y, Z positions in our position array. We can use this as X, Y, Z scale values in our scale array, or RGB colors in our color array. It's very versatile. So let's just plug this outlet of the same jit noise to these 3 inlets. Here it is, not very pleasing to the eye, but it looks like something is happening. There is a bunch of objects. They're obviously a bit too big. They're all smushed in this corner, and they're all expanding and or moving to the right and to the top. And this is because, the way we think of coordinates in jit.gl. has a different way of working than jit noise. In jit noise, the ranges go from 0 to 1, but in our coordinate system here, 0 is the middle point, and going to the right or going up is going from 0 to 1, but going to the left or going down is going from 0 to -1. So we have to make it, we have to scale this information, we have to make it so jit noise sends out a bunch of random values that don't go from 0 to 1, but from -1 to 1. And there is not really a jit.scale, I believe. Yeah, there really isn't. But we can use jit.map, the equivalent of scale or scale tilde, MC scale, and so on. It works a bit differently. I need to give an attribute of map, and then I can type in my range of values. And in this case, I'm receiving a matrix whose ranges goes from 0 to 1, and I want to scale it from -1 to 1. So if I take the output of jit noise, I send it to jit map, and there we go. It should be fixed. It still looks very goofy. It still looks a bit silly. And that is probably because of the information going to the scale inlet, but we will deal with that later. The point is, right now we created a jit.gl shape, we connected it to jit.gl.multiple, and we gave it the right parameters. So sending jitter matrices containing the right data creates multiple objects on the screen. Okay, cool. Now let's go back to MC. Let's go back to the world of MC, and let's see how we can get data out of MC, and we can somehow smush it into a jitter matrix and then send it to jit.gl.multiple. So for example, let's start with the pen. Right, if you remember, this object right here at the end sends out a 10-channel MC signal containing the pen values of each individual channel that should go from 0 to 1, 0 meaning all the way to the left, 1 meaning all the way to the right. So I'm going to start by, I'm going to start with creating an MC snapshot. This is going to convert the signal values to numbers. And I don't need to give as an argument the amount of voices in my MC signal because it is going to receive this 10-channel MC signal and it will know immediately what to do with it. Here's the thing though, I'm going to turn off audio for now, or at least turn down the volume. And if we try to look at what is coming out of MC snapshot, you will see that it does not really send out a list. Right? In fact, it is not sending anything right now because I have not triggered these load messages. Should be sending something, right? Or maybe it is sending a different kind of data. Ah, no, I know what's wrong. I have done this mistake so many times. Problem is you need to tell MC snapshot the reporting interval. Right? You need to tell it in milliseconds how often it should, well, take a snapshot of the incoming audio. So let's make it a nice 55 and let's try this again. There we go. Okay, so what is going on here? The first outlet, left outlet of MC snapshot is sending out a value, and the right outlet is sending these messages, voice 10. It's in fact sending a bunch of messages that go from voice 1 to voice 10. So what is happening here is MC snapshot is not sending out a list. It's just sending each individual voice's value separately. All right, so we have to find a way to pack this into a list. And I believe there is something that is the opposite of MC lists. I believe it was called MC make list. Here it is. It will create a list from non-signal output of MC objects. This MC make list is pretty much created to work with MC snapshot and the like. If you look at the help file, you can see that it takes these two outlets of MC snapshot. It's kind of combines it here, and this will create a list containing all the values of all these objects. Right, if you don't believe me, I can simply try to work it here like this. And there you go, 10 unique values all containing the panning values that we are sending to MC Mixdown right here. So we can work with this. Okay, so we have our list. Now let's see how we can put this into a jitter matrix. So first of all, I'm going to create my matrix. I'm going to make it a named matrix, right? So jit.matrix, and then as an optional argument, I can give it a name, and let's give it the name position. right? This panning value is going to control the position. I want it to have, let's see, 3 values, right? It's going to have 3 planes, 3 planes is going to be the XYZ coordinates, float 32, and then the length is going to be 10. Okay, so now we have this jit matrix. It's currently empty, meaning all the values inside this matrix are 0. So we need to do something to put all of these guys into all of these guys right here. And to do this, I'm going to use jit.fill. Right, jit.fill needs a few arguments as well to work. It's going to take a bunch of values and it's going to put it inside a jitter matrix. If it is connected to that jitter matrix, it's also going to send out a bang, triggering that jit matrix. So how it works is it needs at least 1 argument, right? So in this case, the name of the matrix I'm going to fill, which is going to be position, and then optionally which plane it is going to fill. And we count from 0. We count starting from 0. So I want it to fill, let's say, the x-axis, right? I want it to move from left to right, which is the x-axis. So it's going to be 0. So now if I do this and then connect it to my jitter matrix here entitled position, I can create another jit cell block and see what is going on. Okay, so nothing seems to be going on. This jit matrix isn't even sending anything. Of course. Okay, another silly, dumb mistake right here. What I did was I filled this message box, right, by using the second inlet, which is a cold inlet, meaning this isn't sending out anything. And then when this, since this is not being sent, jit.fill is not doing anything. A lot of mistakes today. Okay, so I need to kind of regularly bang this at an interval to be able to send the values to their right places. Right, and I have a nice trick for doing that when it concerns jit.world. I just take the second outlet of jit.world, which is going to bang after each frame is drawn, meaning if this is running at 60 FPS, 60 bangs per second. So I'm going to use s-metro, so I'm just sending this message, in this case this bang, to a receive object called metro. I'm going to do r metro. If I connect it here, now it is sending 60 bangs per second, meaning that this jit matrix position is being updated at a regular interval. Okay, and just like before, I'm going to use jit map to map these values between -1 and 1, and then I believe I can send it to my jit.gl.multiple. Let's see what happens. All right, okay. Still doesn't look very good, but it's getting somewhere. First of all, the scale is still a bit messed up, and they're all on the same plane. I would prefer them to be on, different Y positions as well. But other than that, it looks nice. So maybe how we can fix it is we initialize this matrix, this jit matrix position, by giving it a bunch of random values for x, y, and z coordinates, and then we overwrite those x coordinates by using our jit.fill position, our metro trick. Right, so what I will do then is I'm going to take the output of this jit.noise, scaled to -1 and 1, and I'm going to send it to my jit matrix position. What this will do is it will, momentarily change all the values in that matrix according to that value, but then on each bank, the first plane, meaning the x position, is going to be filled by different values. So if I do this, as you can see, the x and y positions are different, but the y and z positions are different, but the x position is controlled by the pan. We can even listen for it if we want. I can make it so, let's say, like this maybe. Okay, we are making progress. So now let's move on to the matter of scale. Now, scale is going to be a bit more hairy because, we have a little problem. Scale expects a matrix of 3 planes to, signify how much, the size of it in the x-axis and the y-axis and the z-axis. That's why all of these objects look all smushy and weird right now. Right, but we are going to get a single piece of data from our MC object concerning amplitude. So we have to find a way to take the single value and fill each plane of a JIT matrix with that same information. All right, so let's see. To get amplitude, well, I can use peakamp, or more specifically, I can use the MC version of peakamp, right? And I'm not going to make the same mistake I did with mc.snapshot. I'm going to immediately give it the right argument so that it reports the peak amplitude. Well, it just reports the peak amplitude. And then I'm going to take the outlet of MC groove here, which contains the 10 channel multi-channel signal containing the playback. And I'm going to plug it into this mc.peakamp here. And if I take my make list and if I take my message box here, if I do the exact same trick, I should be getting 10 values, but this time they're not the actual values of the audio signal, but the amplitude of the incoming audio signals of each channel that is coming through with this MC patch cord. All right, so let's once again create our jitter matrix. So I'm jit matrix scale and then 3 float 32 10, the same parameters except the name. Okay, and this time I'm not going to use bangs. In fact, I can kind of fix this too. Instead of sending these bangs, I can simply send this list to jit.fill instead of putting it in a message box and then triggering it, which does make more sense now that I think of it. And I'm going to do the same thing here. The only difference is I'm going to create 3 jit.fills, right? Jit.fill scale 0, jit.fill scale 1, and jit.fill scale 2. And doing this will ensure that each plane of the JIT matrix called scale is set to the same value. Now I don't need to connect all of these to my jitter matrix. This wouldn't make sense because these just send bangs when they are done. These don't, if this jit.fill is not connected to this JIT matrix, it doesn't mean that it doesn't fill it. It still fills it. It's only a matter of triggering this JIT matrix, sending the matrix it contains to another object. Okay, so I can simply delete this patch cord and connect it here like this. Whoa, okay. All right, it's getting a bit crazy here. So this does seem to be working. It is a bit jittery, it's kind of shaking around, and these objects are a bit too huge, aren't they? So I might also want to kind of scale down this jitter matrix, and I can do this by using jit.op. And I can use the op attributes to say I want to use multiplication, and I want to multiply the incoming value with, let's say, 0.25. And there we go. Okay, this is a bit better. So now it's the same scale values. They're all just scaled down to 1/4 of the initial value, which means pretty much smaller objects. Right, I can also modify my jit.gl camera to be a bit closer to the screen. Okay, there you go. Looking much better already now. They really look like spheres. I don't like the fact that they're super jittery though, so I am also going to use jit.slide, which is going to, well, slide the values logarithmically so that the motion is more smooth when I'm going through one range to the other. And again, with jit.slide, I need to give it an attribute of slide up and slide down. So let's try slide up 10, slides down 10, and see how this looks. Oh, much better. This already looks much better. Maybe 15 would be nice as well. Okay, so as you can see, this completely following the panning, and the size of these objects are determined by the amplitude of each channel. We have in our hands a visualization of our MC installation. And by using this JIT noise, I'm able to send, well, random colors. I'm able to set random colors as well as the Y and Z positions of each instances of my object. So this can be really useful. To make it look a bit better, I can also change the background. For example, I can give it the attributes erase underscore color 0, 0, 0, 1. If I restart this, there we go. It can't really be like space. Maybe you can combine this with my previous video about creating a solar system. Maybe those could be audio controlled. Or if we want, we can type in erase color 000 $1, so I can set the transparency, the alpha channel of the background, so that they leave these cool trails as they move around. And as you will see, changing the panning algorithm is going to change the movements of these objects without us having to set anything, because they are controlled by these patch cords. Well, there you go. I hope this was informative for you, and thank you for watching.